I was looking through this lesson, and I kind of skipped over this first section. I saw distance formula, midpoint formula on this lesson, and a whole bunch of other stuff. And for some reason, when I first taught this the first day, I just went right to the distance formula. And I skipped over something that you're going to see if you take a college algebra class in college. They're going to talk about this kind of stuff. So I debated whether to leave it out or not. But I think I need to discuss it because I don't want you to go to college and say, Mr. Hamrick, you never talked about that. So here it is. This is an Algebra 2 principle. You've done this in Algebra 2. You probably did maybe a little tiny bit in Algebra 1, not a whole lot of it, but in Algebra 2 you probably talked about this a little bit more. In Geometry, we never really discussed it in Geometry at all. Okay, this is kind of more of an Algebra 2 topic. Do you remember this? Actually, let's do it the other way. Let's go domain and range. Do you remember those words at all? Okay, domain and range. So what are we talking about when we talk about the domain and the range? Well, you could actually look at an ordered pair to find the domain and the range. An ordered pair is x, y. The domain is the x part of the ordered pair, and the range is the y part of the ordered pair. This is the first time I ever saw this. This was in college, and this, I don't know, seems to help me a little bit. We call this a function machine. And we'll talk about functions in the next lesson, but right now we're just going to talk about the domain and range. So for instance, this could be any function like y equals 2x. That's all this machine does. Okay? If you stick a number in, you get a number out. Okay? So if you put a number into this machine, what are you putting in? You're putting in an x value. Right? You stick it in here, and what does this machine do? The only thing it does is not good for much. The only thing it does is do what? It takes that thing that you're putting into the machine and does what to it? Multiplies it by 2. That's all it does. That's the only thing it does. Okay, not a very good machine, but that's what it does. So if I stick a number in, okay, it's going to give me a y value. So we're putting in a domain, and it's going to give us a range. Okay, so we're going to put in a domain. For instance, if I put in a 3, what's it going to kick out right here? It's going to kick out a 6, isn't it? It's the only thing that little machine does. Okay, is it takes a number, when you plug it into that machine, that's kind of like your funnel, right? It's going into the machine. Everybody get that? Okay. I didn't come up with this, all right? I did. I had a professor in college who used to do this, and it kind of helped me a little bit understand. So if I take this and I stick it into this machine right here, it takes that x, or that domain, right? Call it D for domain, and it kicks out a y value. So y is equal to 6. Well, what is that answer? That answer is the what? Is the range. And the number that we put into that machine is the domain. Okay? Now, let's talk about this. Are there any restrictions on what I can put into this machine? Is there anything that I can put into the machine that's not going to work? For instance, can I put in, well, I put in a positive number already, right? Does it matter how big or small that positive number is? Could I put like 1,000,000? Yeah, because that machine's just going to do what? It's going to go 2 times 1,000,000, right? Which is 2,000,000. That's fine. Could I put in 1,000,000,000, 1,000,000,000,000? Does it matter how big of a number I put in? No. What about how small of a number? Can I put in a negative number for this? Sure I can, because I can take a negative number and multiply by 2, can I? All right. What about the numbers? And what are my answers going to be? Do I have any restriction on my answers? Are my answers always going to be positive? Are they always going to be negative? Could I put a 0 in for the domain? Yeah, because 2 times 0 is 0. So I could get a 0 answer, couldn't I? So I could get a negative answer, I could get a 0 answer, I could get a positive answer. There's no restrictions. What if I stuck in a fraction? Can I put a fraction into this? Sure, I can take a fraction multiplied by 2. I can take any real number. Now notice what I said. I can take any real number, put it in for this, and I come out with another real number. You say, well, of course, that's ridiculous. I can take any number multiplied by 2, right? There's no restrictions. So there's absolutely no restrictions on the numbers that I can put in for this. You with me on that? Okay. So what we're going to do, they're going to take an equation like y equals 2x, and they're going to say, what is the domain of this equation? What is the domain? Meaning, what numbers could I use for x? What are my possibilities that I could use for x? What is the domain? Well, what do you think? All the real numbers, that's right. Now, how do we write that? How do we write all the real numbers in that interval notation? Remember we wrote interval notation? So what are all the numbers on the number line in interval notation? That's right. It goes from what? Negative infinity all the way to what? Positive infinity. That means every single number on my number line. Would you agree? Okay. So what's the domain of this? It's every single number. There's no restrictions at all. I can't say, well, you can put every number in for x except for whatever, and it's not going to work. No, you can take any number in the world, okay, any number on the number line, put it in for x, and you can get some kind of answer, right? What about the range? What about my answers here? Was I restricted on any of my answers? No, I could get negative answers, I could get 0, I could get positive answers, right? So what is the range then? It's all the real numbers as well, which is negative infinity to infinity. So if I gave you a formula like this, the domain are all the real numbers and the range are all the real numbers. In fact, any linear except for if it's horizontal or vertical. Okay, we'll say that. I hate to say any, but almost any linear equation except for if it's a vertical line or a horizontal line, the domain and the range will be all the real numbers. So for instance, if I gave you an equation like this, if I said 3 halves x minus 1, if I gave you something like that, I could put any value that I wanted in for x, and I'm going to get a number for y. Okay, I'm going to get a value for y. So there's no restrictions on what my x is going to be, and there's no restrictions on what my y is going to be. So how do I show that when it says find the domain and range? I show it like this. That would be my answer right there. Okay, that's all the real numbers. So if it's linear, if it's y equals mx plus b, that's linear. Your domain and range is always going to look like this. And you say, well, okay, well, what situation would I maybe have some restrictions? Well, it's a good question. I'm glad you asked that. You guys are thinking. Right? Did you ask that question? No? Okay. Well, I'm thinking then. Watch this. What about this? Now think of our little function machine. Here's our little function machine. Right? And we're going to put numbers in here, and we're going to crank out an answer. What does this thing do? This thing right here, all it does is take what number I stick into it and does what to it? Square roots it, right? Okay? So, for instance, can I put in, I don't know, a 1? Can I put in x equals 1 here and get an answer? Yeah, because can I take the square root of 1? Sure, absolutely. I'll get a 1 if it comes out. Actually, I get a plus or minus 1, won't I? If I take the square root of it. What about a 2? Can I put a 2 into that thing? Yeah, absolutely. I could put a 2 in here. Now, it doesn't come out to be a nice, pretty number, but it does come out, right? It's what? It's the square root of 2. Or if you put that in your calculator, square root of 2, 1.414 about. So we'll say 1.4. So it's approximately 1.4. Yeah, we get an answer. Do we have any restrictions, though? Can I put in any single number that I wanted to for this? I could put in a fraction, couldn't I? I could even put in 0, right? If I put in a 0 here, what's the square root of 0? Square root of 0 is 0. Put it in a calculator, it works. Okay?
Can you put in a negative?
That's a good question. Now, I am glad you asked that. Can you put in a negative into this? So like the negative 4. That's correct. An imaginary number does not lie on the number line, does it? Okay, it's not a real number. That's why we call it imaginary, because it's not real. So I cannot put in a negative 4. You follow me? Okay, so let's think about this. What is the domain? What are all my possibilities of numbers that I can put in? What's the very smallest number that I can put into this machine right here? 0. Because as soon as I go smaller than 0, that's a negative number, isn't it? Okay, and I can't put in a negative number. But do I have any restrictions on anything greater than 0? Not, because I can put in any single positive number that I wanted to. I could stick in a decimal and it would work. I could stick in a fraction. I could stick in a whole number. I could stick in a giant, big old number. I have no restrictions on my positive numbers. So what would it go to? It would go from 0 to infinity. Okay, that would be my domain of this little equation right here. Yes. Very good. I'm glad you said something because I was so used to putting those Parentheses, right, because it's not open, it stops right at 0. And we can include 0, right? So since we can include 0, you're absolutely right. We put a bracket at 0. Okay? What about the range? The range are all my answers. Now, again, we're only restricted, but we're restricted between 0 and infinity. So I can only put in positive numbers, right, in for x. So what kind of answers am I going to get? Now let's say I put in a positive 4. What answer am I going to get for this? What is it? It's the square root of 4, right? Which is what? It's plus or minus 2, isn't it? Everybody see that? It's plus or minus 2. So my answer, okay, to this thing right here, I can actually get two answers. I can get a positive 2 and a negative 2. So what kind of answers can I get for my range then? I can get positive answers. I can get negative answers. I could also get what? 0 for an answer, right? So say it, Ashley. What'd you say? That's right. So it goes from negative infinity to positive infinity, and that is open on both ends. You see the difference? The domain is the numbers that I'm putting into my equation. All right, so I'm restricted. I can only put in from 0 on up. I can't put negative numbers into this thing. So that's my domain. But what's my answer, though? Once I do stick in a valid number, right, a positive 4, let's say, what's my answer going to be? It's going to be a positive 2, and it's also going to be a negative 2. So I could get negative answers, right? I just can't put negative numbers into it. Does that make sense? All right. Let me ramp this one up a little bit. Watch this. What if I said, I'll tell you what, let's do this in a different color just so it's different. Y equals the square root of x plus 2. Now what if I did this? Now what did we say about the domain here? The domain had to be what? Greater than, right? Greater than or equal to 0, correct? Now you got to be careful here. We're not just going to say x has to be greater than or equal to 0. We're going to say everything underneath the square root has to be what? Greater than or equal to 0. See what I just did? I set this greater than or equal to 0. What did I do here? I set this domain, all this stuff underneath the square root, I set that greater than or equal to 0. Because remember, everything inside the square root has to be greater than or equal to 0. For instance, can x equal negative 1? It can, right, because negative 1 plus 2 is what? Positive 1. Can I take the square root of positive 1? Absolutely. So in this case, x could possibly be a negative number. X could also be a negative 2 if I wanted it, couldn't it? Negative 2 plus 2 is 0. I can take the square root of 0. But let's see what we're going to do. If I said x plus 2 has to be greater than or equal to 0, what does x have to be? Well, we subtract 2 from both sides, so x has to be what? Greater than or equal to negative 2. All right? It's got to be greater than or equal to negative 2. And we already picked a couple, didn't we? We picked negative 2, and that's fine. I picked negative 1, which is greater than negative 2, and that's fine, right? I could stick a 0 in here. 0 plus 2 is 2. Can I take the square root of 2? Absolutely. See what we just did? So anytime you have a square root, what you're going to do is you're going to take the stuff inside the square root, you're going to set it greater than or equal to 0, and that gives you your restriction. Now how do I write this? This is my domain. How do I write this as a in interval notation? It's greater than or equal to negative 2. So it's a bracket, starts at negative 2, and it goes everything what? To infinity. That would be your domain. We good? What about the range? Now, I don't care what you put in. As long as you put in a good number for x, what kind of an answer am I going to get? I could get a positive answer, I could get a negative answer, or I could possibly get what? 0. So what's my range going to be? All the real numbers. So negative infinity to infinity. All right? Yeah, it's as long as you understand what that means. I like that little function machine because you think about putting a number in, getting a number out, you know? And I think that makes things a little bit easier. So you can thank my college professor, Dr. Wooldridge. Shout out. Math shout out. What a dork I am. All right. Let's do another one. What about this? Y equals absolute value of x. What about this? Again, let's think of our function machine. And what does this thing do? It just takes the absolute value of a number that you stick in here. Alright? Let's think about it. What numbers can go into this machine? Remember, this is absolute value. That's not a 1. That's a absolute value. Yeah, think about it. Do I have any restrictions? No, because if I take the absolute value, all it does is take that number and makes it positive, right? So I could put any number I want in for this. Would you agree? I don't have any restrictions whatsoever. So my domain are what? All the real numbers. I could put a negative number in here. I could put a 0. I could put a positive. Correct? Agreed? Yeah. So my domain, right, all the numbers I'm going to put into here is any number I want. I don't care. I can put a fraction, put a decimal, positive, negative, 0. That covers all the real numbers, doesn't it? Okay. What about the range, though? Let's think about the answer. For instance, if I stuck in, let's put in like a 3. What if I put in a 3 for this? Y is the absolute value of 3. What is the absolute value of 3? It's 3. It's a positive 3, correct? Okay, so I can put in so I can get positive numbers for an answer. Agreed? What if I stick in a negative number? What if I put in a negative 2? What's the absolute value of negative 2? It's positive 2, isn't it? So no matter what number I put in, well, let's put in a 0. What if I put in a 0? What's the absolute value of 0? It's 0. So look at my possible answers. I stuck in a positive, got a positive. I stuck in a negative, and I got a positive. I stuck in a 0 and got a 0. So what do you think my range is? That's right, it's 0 to infinity. It's just from 0 and then all the positive numbers. I can never get a negative answer for this. You follow me? Because when I stick in a number, no matter what it is, if I take the absolute value of it, I have to get a positive answer or a 0. Right? I can't get a negative. I cannot, I should say, get a negative answer. So how do I show that? From 0 to infinity. And that's your range. Hopefully this is making a little bit of sense to you. Do you remember doing something like this in Algebra 2? Yeah. Alright. Are you getting it now? Okay, good. Let's see what else. Let's do this. I'll change this up just a little bit like we did the other one. Orange. What if I did this? X minus 3. What if I said this? Now again, what did we do? We said this could be any number at all. Would you agree? All right. So what about this? Does it matter what I put in for x? No? Because there's no restrictions. It's not like I take this whole thing and I set it greater than or equal to 0 like I did with the square root. Okay, I could put any number that I want in for x. All right. So what's the domain then? It's all the real numbers. My infinity is getting a little, looking like an 8. I got to slant it a little bit more. What about the range? Same thing as it was before. So that didn't really change, did it? Okay, whether I put something inside the absolute value or not. So the range, okay, I could get a 0 or I could get anything positive. There's no way I'll get a negative answer. It doesn't matter what I put in for this. There's no way I'll get anything negative. All right? What if I did this? Now let's think about this. Watch. What if I put... What if I did this? First of all, let's think of domain. What kind of numbers can I put in for x? Any number that I want. Okay, so it's still negative infinity to positive infinity. What about the range, though? I stuck a negative out in front of it, didn't I? Could I get a positive answer? No, because if I stick a number in for x, the absolute value of that, no matter what it is, will be positive. But this thing will make that positive a what? A negative. So can I get any positive answers for this? No. But I could get a 0, though, couldn't I? Right? I could get, because if I stick a negative 2 in for this, right? Negative 0 is just 0. So I could get 0, but every answer is going to be negative this time. So it's going to go where? From negative infinity to 0. Good. Bracket. Good. See the difference? All right? So it takes a little thought. It's not like you can just look at, the absolute value and memorize and say, oh, it's always going to be this. Well, you got to understand what's going on here. We good? Can we do one more? Let's do this. This is the cube root. It's a little different. Remember, square root, you can't take the square root of a negative, but can you take the cube root of a negative? Yeah, because what's the cube root of negative 8? What number times itself 3 times is going to give you negative 8? 2? Negative 2, right? Not just 2, because 2 times 2 times 2 is positive 8. But what gives you negative 8? Negative 2, right? Negative 2, negative 2, negative 2 is negative 8. So you can take the cube root of a negative. You can take an odd root of a negative. You can't take an even root of a negative, but you can take an odd root of a negative. So are there any restrictions for x right here? There's not, because I can put a negative number in for this, I could stick 0 in for this, or I could put a positive in for this. So what's the domain? All the real numbers, from negative infinity to infinity. What about the range? Well, it all depends on what x is, right? If I stick in a positive number, if I did the cube root of positive 8, what kind of answer am I going to get? I'm going to get a positive 2, aren't I? So it all depends. If I stick in a negative, I'll get a negative. If I stick in a positive, I'll get a positive. If I stick in a 0, I'll get 0. So what's the range of this? It's all the real numbers again. And that's how you want to think about this. What numbers are you allowed to put into this thing in order to make it, in order to get a real answer? And that's what you're looking at. I hope that made sense. I think it did. You guys seem to think that it helped more than what you did in Algebra 2. So sometimes just hearing it another time helps you a little bit. All right. So that should help you out. I'm going to give you a worksheet today. If I can go get it copied. Every time I've gone to the copy machine or room today, somebody's been using it. So hopefully I can get it copied for you. I'll give you the worksheet. So there's only a few of these new ones. The rest of them are old stuff from what we did before in 3.1, okay? All right, that's it.